Okay, so let's go stepwise with net ionics this year. So I'm going to start with what I think are the two simplest ones to do, which are net ionics for precipitation and net ionics for dissolution, which are kind of inverses of each other. So if we're going to combine solutions of barium nitrate and sodium sulfate, and we want to see what is going to precipitate out, the first thing you need to do is think about your potential products and your solubility rules. Right? So I'm just going to show you this here. So I went ahead and wrote out what we call a molecular equation, which you don't actually have to do for a net ionic, but when you're just learning, I think it's helpful. So your outsides can combine and make a new product, which in this case would be barium sulfate, and your insides can combine and make a new product, which in this case will be sodium nitrate. Now you have to decide which one of these is going to be the solid if you know there's a solid, and in this case the prompt would have told you there was, and which one of these is going to stay dissolved. Now, remember that in AP chemistry, we use the SNAP, okay? If it's in your SNAP, it's going to be soluble every time. So SNAP stands for sodium, nitrate, ammonium, and potassium. So here we have two of these actually. We have our sodium and we have our nitrate. Over here, their purpose was to make these dissolve. Now over here, we know that they're going to stay dissolved. So this is going to be aqueous, so we don't care about it. Because in net ionics, we don't include the ions that are spectator ions, which are things that start as aqueous and stay as aqueous. So here, this must be our solid. So if I come down here and look at this, my BaSO4 is my product. So when I'm writing a net ionic for a precipitation reaction, I like to always start by writing the product. And then what you do is you actually work in reverse and bust it up. Okay, so I can literally pull this apart. So then I've got my barium and I've got my sulfate. And then all you have to do is add your charges. So I've got my Ba2 plus, and I've got my SO4 2 minus, and that is my net ionic for that precipitation. Now let's look at the opposite process of this, which is dissolution. So if you have something like lead chloride and you know it's a solid and you're going to drop it in water, see what it does when it dissolves, you're going to simply bust it up. So lead 2 chloride breaks into, you have to think of it as your ions. So that's Pb2 plus, and you know it's 2 plus because it's combined with 2 chlorides, and then you've now got your 2 chlorides here, okay? So then your net ionic for this is Pb2 plus 2 Cl minus. Super important that you remember your charges in net ionics. It is not a net ionic without your charges. A lot of, like if on the AP exam, for example, you do not have to include states, although some professors and teachers want you to do that. In which case it would look like this, because remember that these guys are represented right there. That's it. So that's how you write a net ionic for precipitation or dissolution. Hope that helps.